Hello, my dear students. It's my pleasure to meet you today. Today, inshallah, we are going to study a new lesson in geometrical lessons. We have studied the last period about the similarity of two polygons. Today, inshallah, we are going to study the similarity of two triangles. Okay? If we have two triangles and we would like to prove that the two triangles are similar, we have many cases. The first case here, if we have two triangles like that, triangle number 1 like that, and triangle number 2, the triangle number 1 called ABC, and triangle number 2 called XYZ. When we call these two triangles are similar, the case number 1 is if we have A similarity. What about A similarity? What is the meaning of AA? If we have two angles like that, if measure angle B equals measure angle Y and measure angle C equals measure angle Z, that means that two angles in the first triangle equals two angles in the second triangle, then we can say that the two triangles are similar. So if the angle B is congruent to the angle Y and the angle Z congruent to the angle C, then we can say triangle ABC is similar to triangle XYZ. And notice, my dear students, about the corresponding points. We know that measure angle B equal measure angle Y, so B here is the corresponding of Y. And we know that measure angle C equals measure angle Z, so we say that C is the corresponding with Z, and of course A will be corresponding of X. And we know that if two angles of triangle equal two angles of another triangle, then the third of course equal the third. So we say that AA triangle similarity, that enough to prove that two angles here equals two angles here, because the third angle equals the third angle. It is not necessary to say here that the second condition is each two corresponding sides are proportional like quadrats, like polygons, because in triangle we have the first case, just two angles equal two angles, and we can say that the two triangles here are similar. The triangle ABC is similar to triangle XYZ. Okay, let's move to an example. We will take an example to explain, to understand well the similarity of two triangles. Let's draw here, if we have a triangle like that. Triangle ABC, and we have a line segment EO and the line segment EO parallel to the line segment BC. Okay, and we have here EB equals 5 centimeter, CB equals 9 centimeter, and AC equals 9 centimeter also. And we have AC here equals half AB. Okay. AC equals what? Here EB equals 5 and BC equals 9. and AC equals half AB equals 6 centimeter. So it's 6 centimeter, not 9. So we can say that AB here is 12 centimeter because it's half, AC is half AB. Okay, what's the length of AE then? We have the total length of AB equal 12 and EB equal 5. To find AE, we will subtract 12 minus 5 equal 7 centimeters. Okay, so AE equals 7, EB equals 5, a total AC equals 6, and CB equals 9. The request is to prove that triangle AEO is similar to triangle ABC. What is triangle AEO? This is triangle AEO here. We would like to prove that this triangle is similar to the bigger triangle or the whole triangle ABC. Okay, that's the first request. The second request is to find the length of the line segment EO and line segment CO. Where is EO? Here is EO and here is CO. We would to find its length. Okay, first we have EO parallel to BC in the two triangles AEO and ABC, and we want to prove that this triangle is similar to triangle, the bigger one. Okay, we know that if EO parallel to BC, then the measure angle AEO equals the measure angle B. And also we can say that measure angle AOE equal measure angle C, corresponding angles from parallel. And we have A is a common angle. It's enough to prove that two angles here in the first triangle equal two angles here in second triangle. So we can say measure angle AEO equal measure angle B, and measure angle AOE equal measure angle C. Therefore, triangle AEO is similar to triangle ABC. So we have the first request. Show AE over AB from similarity. AE over AB equals EO over BC equals AO over AC. Put the length. Where is AE? AE here is 7 over AB, which is 12, equal EO. EO here, we don't know it, over BC, which is 9, equals AO. AO here, we don't know its length, over AC, the total AC is 6. So to find EO here, we multiply 7 by 9 over 12, cross multiplication. So EO equals 7 times 9 over 12, and EO here divided 3 equals 3, divided 3 equal 4. Okay, so 21 over 4 centimeter. And to find the length of AO, we will multiply 6 by 7 over 12. Divide by 6 equal 1, divided by 6 equal 2, so it's 3.5. So AO equals 3.5 here, and OC, of course, equals the rest of 6, which is 2.5 centimeter. And OE equal 21 over 4, approximately equals 5.25 centimeter. Okay, let's move to another example. Do you know about circles? If we have a circle, remember from the third studying that we have in the circles something like inscribed angles and central angles. So if we have a circle here, okay, and we have a line segment AE and another one here, BC, let's draw another one, something like that, and the other one here like that. That's AE, and this is BC. I prefer this drawing because we have here D by 6 BC, so it's logical than this one. Okay, if we have a circle and we draw AE and BC and D by 6 BC here, and the request is to prove that BD power 2 equals AD multiplied by DE. Okay. Okay. Let's move about BC and EA. They must be two triangles to prove that the two triangles will be similar here. Okay, we have to prove that BD power 2 equal AD times DE here. Okay, let's imitate about the two triangles BDE and the other triangle ACD here. Can we prove that these two triangles are similar? Think about that. What about the angle ABDE and the other angle ADC? The measure angle BDE equal measure angle ADCY because they are two vertically opposite angles. And if we look here at this angle EBC, it's an inscribed angle to the arc CE here from the siding of third prep. It's equal the measure of the other inscribed angle EAC. So we have here measure angle EBD equal measure angle CAD and measure angle BDE equal measure angle ADC, vertical opposite angles. And also if we want to talk about the angle BEA, it's also equal measure angle BCA, inscribed angle to the same chord, same arc BA. Okay, so we can write measure angle B equal measure angle A, inscribed angles subtended by same arc CE, and secondly we can say measure angle E equal measure angle C for the same reason, because they are inscribed angles equal in measure because they have the same arc BA. So we can say that the triangle ACD is similar to triangle. We say A first, so we can say B first here because they are corresponding. The angle C is corresponding to E. The angle D corresponding to itself. Okay, and we can say that from the similarity we deduce that AC over BE equals CD over ED equals also AD over BD. And from the request here, we would like to prove that BD power 2 equal AD multiplied by DE. So we will find BD, here it's BD, and AD, here AD, and DE is this. So we can say that BD okay. 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 So BD times CD here equals BD times CD equals AD times ED. Okay. And we know that BD here equal to DC. So BD equal to CD. We can write BD times BD also, because CD equals BD, equals AD times AD times ED. BD multiplied BD, of course, will be equal BD power 2. So it's equal AD multiplied by ED as the request here. Okay, let's revise again. We have here two triangles. The measured angle B equal measured angle A inscribed angles subtended by same arc BA, and measured angle E equal measured angle C subtended by same arc AE, but measured angle B equal measured angle A subtended by same arc CE. So the triangles are similar, and from similarity we have BD times CD equals AD times ED, and we have CD here equal DB from the first, so we can replace CD by BD. So BD times BD equal BD power 2 equals AD multiplied by ED. Okay, and it is the request now. Let's move to another example. Do you remember my discussions about cyclic quad? We have studied last year about cyclic quad. What about cyclic quad? What is the meaning of cyclic quad? We know if we have a circle like that. So if we have a quad like that inside the circle, we say that A, B, C, D is a cyclic quad. And we have specific properties for this cyclic quad. We have each two opposite angles are supplementary. The two angles are supplementary means their sum equals 180. So if this angle will be 110, this angle will be 70 degrees. And we can say that the exterior angle like that, we have BCE here is exterior angle of the quad equal the interior angle opposite to its adjacent, okay, on the same vertex. So this angle here equal 110. And my dear students, vice versa. If we have an exterior angle here equals an interior angle which opposite to its vertex, then BCDA is a cyclic quad. And also, if we have a quad like that, and we join these sides, so if we have an angle CBD equal measure angle CAD, two angles have the same side, same base, and on one the same side, so the two angles makes the quad ABCD cyclic. That means that a circle passes through A, B, C, and D. Okay? So if we have a triangle like that, triangle DEO, and this is the X, Y, okay, and we have an angle here which DXY is equal to the angle O. So we can say that the quad YXEO is what? Is a cyclic quad, because here an exterior angle equal the interior angle opposite to its vertex here, which is O. So XEOY is a cyclic quad. Okay, let's move on this question. Here we have dy is 5 centimeter and yo is 3 centimeter and the x is 3 centimeter also, and the request is to find the length of XE. Where is XE here? Is this one. Okay, so let's prove that the triangle DXY is similar to triangle DOE to have ratios equal each other to find the length of XE. So to find the length of XE, we must prove that the triangle DXY is similar to triangle DOE. How can we prove that? The triangle DXY and triangle DOE have the same angle here, so the angle D here is a common angle. So we say we have an angle here. That's the first condition. And also we have measure angle DXY equal measure angle O. So we have two angles here in the small triangle equals the two angles here in the big one. So the two triangles are similar. So we can say that the triangle DXY is similar to triangle. When we say D, we will say D also, because D is the same angle in the two triangles. X here is equal to O, so X the second, so O the second. Okay, and also we say that DXY, we have here DOE. Okay, this is E. So we have two triangles are similar, and now we can write the ratio from similarity of two triangles. We can say that dx over do equals xy over OE okay, Okay, so dy equals dE, and by substitute we have dx here equals 3 centimeter over do. do here equals 5 plus 3 equals 8 centimeter. xy, we have no length for xy, and OE, we have no length for OE, equal dy. dy here is 5, and DE here. What about DE? DE, we don't know the length of DE. We know also about dx, which is its part, equals 3 centimeter. So we have to find the length of BD, DE. Okay, to find DE here, we will make cross multiplication. DE equals 5 times 8 divided by 3. Okay, 5 times 8 equals 40. 40 over 3, about 13, approximately 13.3 centimeters. Okay, and we have the x here is equal 3, so xe equals 13.3 minus 3 equals 10.3. This is approximately, because you have here 0.3333 and so on, so we say approximately 13.3, and we will subtract the length of dx from the total length of DE to have xe. So xe here equals 10.3. Okay, let's move to another corollary here. Let's revise about the first case of similarity of two triangles. If we have two triangles and we have measure of angle of the first equal the corresponding angle of the second, and another angle of the first equals second angle of second, so the two triangles are similar. What about other cases? We have here many cases. If we have two triangles here, okay, if we have triangle here and another one here, if we have triangle ABC and triangle XYZ, and we have measure angle A equal measure angle X, and these two sides here are proportional, AB and corresponding side XY are proportional with the side AC and XZ. If we have these two angles, and these two angles include between two sides, the two sides are proportional, then we can say that AB over XY equals AC over XZ, and we have, this is the first condition, and second one, that the included angle here equals the included angle here between the two sides. So if we have measure angle A equal measure angle X, so we can say that the triangle ABC is similar to triangle XYZ. Say that XY here equal 5 centimeter and AB equals 10, XZ here equals 4 centimeter and AC equal 8 centimeter. So we can say AB over XY here equals 10 over 5, and AC over XZ will be 8 over 4. Okay, these two ratios are equal because they are 2. So if these two ratios here are equal and the included angle between the two sides here and two sides here are equal in measure, so the two triangles here are similar. Okay, let's move to another example. Okay, if we have a triangle like that and a triangle like that, we call this ABC and this XY. Okay, yes, 3 here is 6 centimeter, this is 4 and this is 5. That means that the total here is 8 centimeter. Okay, and total here is 6. We have here AX over AC equals 3 over 6 equals half, and also AY over AB equals 4 over 8 equal half also. And we have included angle, it's the same angle here for these two triangles. Measure angle is a common angle, so we can say that triangle AXY is similar to triangle ACB. Okay, my dear students, let's take a little break and we will return back to you. Don't go away.
ما شافهاش يبقى حياته لسه ما عاشهاش. مصر الحارة جنان العمارة قعدت سلم طول الليل. مصر الشاب الجدع الشاب بنت بترسم بلدوسة. مصر الزحمة مليانة رحمة ايد بتعدي وايد بتشيل. وكوباية شاي عالرايق تفوقك لو متضايق. ونكتة ضحكت من القلب. وحمص الشمع الكورنيش. وخد طبق فول ورغيف عيش. وقعد وغمس هنا على جنب راضيين نعيش فيها عالقد. وهي دي مصر اللي بجد. في مصر تروح في أي مكان. في ناس مختلفة في الألوان. لكن نفس الطباع بالظبط. وفي التكعيب قاعد شيخ. في تشقيق وشه تقرا تاريخ. بيخبط جوه قلبك خبط. بنصلي جمعة وقداس حد. وهي دي مصر اللي بجد.
Okay. We have again which other? We have two triangles. If we have parallelism, if we have triangle like that, we will draw triangle. Okay, and triangle like that. Okay, and we have a parallel line here intersect the two lines A, B, C here, X, Y here, and they are parallel. Also here we have expand of the triangle, and we have X, we have XY, and we have A, B, C. It's the original triangle here, and we have BC parallel to XY. And also if we have a triangle like that, ABC, and we have expand like that, and we have also XY here is parallel to parallel to BC. We know that when two parallel lines are like that, we have two angles are equal in measure, corresponding like that. And here we have the two angles also are equal in measure, and here we have also equal measure angles. So the triangle ABC will be similar to the triangle AXY. The triangle ABC will similar to triangle AXY. Here triangle ABC will be similar to triangle AXY. So if we have parallel side intersect the two sides of triangle internally like that or externally like that and that, so we will have two triangles, the small one and the big one, we will be similar to each other. Okay, let's move about the example. If we have this triangle specifically, and we have AX here equals 33 centimeter, and XB equal 22 centimeter here, and we have XY equals 2x minus 3 centimeter, and we have CB equals 3x plus 1 centimeter also, and request to find the length of x or the value of x. Okay, first we must prove that the two triangles AXY is similar to triangle ABC, and as we said that XY parallel to BC, so directly the two triangles are similar. The triangle AXY is similar to triangle ABC. If we want to talk about steps, we have measure angle AXY equal measure angle B, corresponding angles, because XY is parallel to BC, and we have also measure angle AXY equal measure angle ACB, corresponding angles, and we have also measure angle A is the common angle between the two triangles, the small one and the big one. So we can say that the triangle AXY is similar to triangle ABC, and we can say that AX over AB will be equal XY over BC, also AY over AC. What the answers here? We have AX here equal 33, so write 33 over AB. AB here was the sum of 33 plus 22, so it's 55, equals XY, which is 2x minus 3, over BC, which is 3x plus 1. We know this number, we can simplify it. Divide 11 here will be 3, divide 11 will be 5, so it's 3 over 5 in simplest form. And we can, from the ratio of the third prep, we can multiply here, cross multiplication. We have 3 multiply 3x plus 1 equals 5 multiply 2x minus 3. To multiply here 3 by 3x, we will have 9x plus 3 multiplied by 1 equals 3 equal 5 multiplied by 2x equals 10x minus 5 times 3 equals 15. So we have here 9x plus 3 equal 10x minus 15. And we will transfer here 10x to be negative, and 3 will be negative also. So here 9x minus 10x equals negative 15 minus 3. Okay, 9x minus 10x equal negative x, and negative 15 minus 3 equal negative 18. So we can say that x here equals 18. Okay, x here equals 18, and this is the first request. And the second one, we have already proved that the triangle AXY is similar to triangle ABC. Okay, let's move my dear students to a similar question. We have two triangles also, and two triangles are intersecting like this drawing here. We have a small triangle and big one. This triangle called CBA, and this called ED. And we have CB parallel to DE here. The data, we have the length of CB equal 5 centimeter, and the length of AB equals 3x minus plus 1 centimeter, and this is 2.5 centimeter, and AD equals 2x minus 1 centimeter. And the request is, number 1 is to prove that the triangle ABC is similar to triangle ADE, and the second one is to find x. Our solution will be, first we have two triangles here, this triangle and this one, and we have parallel. We have know that if CB parallel to DE, then the measure angle B equal measure angle D, alternate angles, and also measure angle C equal measure angle E, the other alternate angles. And we have measure angle CAB equal measure angle DAE, vertically opposite angles. So these two triangles are similar. It's enough to say about two angles only. So we can say, since CB parallel to DE, therefore measure angle B here equal measure angle D, alternate, and also measure angle C equal measure angle E, alternate also. So these two triangles are similar. Therefore triangle ABC is similar to triangle ADC, and we will write concentrate about the corresponding angles. Here measure angle A, it's A itself, because here vertical opposite angles. B is corresponding to D, because measure angle B equal measure angle D, and C equals measure angle E, because they are alternate. And we can deduce the ratio AB over AD equal BC over DE, and equal AC over AE. Let's replace these sides. AB here will be 3x plus 1 over AD here equal 2x minus 1. What about BC? BC here equal 5 over DE equal 2.5. So in simplest form, this number will be 2, or we can say 2 over 1. What we call this number from the last period? We call it K. What's K? K is the ratio of similarity. Ratio of similarity. And ratio of similarity here, K equal to greater than 1. So the first triangle ABC here is enlargement to the triangle DEE. Okay, let's concentrate here about our question. We multiply 2 by 2x minus 1 equal 1 times 3x plus 1 will be itself, because any number multiply 1 equal 1 equal the same number. 2 times 2 equals 4, so it's 4x minus 2 times 1 equals 2 equals 3x plus 1. We move 3x here to be negative 3x, so we have 4x minus 3x. Okay, 1 plus negative 2 will move here as 2. So we can say 4x minus 3x equal x, and 1 plus 2 equals 3, so x equals 3. Okay, and here we end the lesson and we end the question for you. Okay, my dear students, I am pleasure to meet you today. We have finished the first and little more about the second case of similarity of two triangles, and the next period inshallah we are going to study and complete the geometric lesson, which is cases of similarity of triangles. Okay, goodbye and good luck.